Dear students, welcome to the Teachers Knowledge YouTube channel. Today in the geography series, we will discuss about the different shadow zones for the earthquake waves. In the previous lecture, we have discussed about the different types of the earthquake waves, body waves, surface waves, P waves, S waves, Rayleigh waves, and so on. Body waves are those which are originated from the focus and moves in all directions of the earth body. Surface waves are those when the body waves are interacted with each other, generate the surface waves which propagate the outer surface of the earth. There is a different types of the body waves like P waves, primary waves, S waves, secondary waves. Primary waves are those which are propagated in the longitudinal direction, and secondary waves are those which are propagated in transverse direction, like the waveform. So, if you had not read this lecture, please go through the channel's playlist and lecture number 11 of the geography series. Firstly, understand the concept of the earthquake waves. Then there is an emergence of the shadow zones of earthquake waves. Then read that lecture. So today we will discuss about the shadow zones. Let's start the concept of the shadow zone. There exist a specific areas where the waves are not reported by the seismograph. Seismograph is an instrument for the measurement of the earthquake intensity. There is some specific areas on the earth where the waves are not reported by the seismograph. These are called the shadow zones. Means shadow zones are those where the waves are not reported by the seismograph. Some specific areas arises in the movement of the earthquake waves. There is some key points about the shadow zones. These are different for the P waves and S waves. Means shadow zones are different for the different types of the waves. They also vary with each earthquake. Means for the different types of the earthquake, there is a variation of the shadow zones, because the earth is spherical and there is all the measurements are angular. So the angles are measured with respect to the epicenter in all the discussion, right? Let's start the key concept of the shadow zones. There is a basic three conditions. When the seismograph located at any distance within 105 degree from the epicenter, there is arrival of both P and S waves. This is the condition number one. Let's understand with the help of example. See, this is the epicenter. This is the 105 degree. So in this region, in 0 degree to 105 degree area, there is arrival of both P waves and S waves. See, in S waves also. So 0 degree to 105 degree, there is arrival of both P waves, S waves. Means seismograph records P waves and S waves. So there is no shadow zone. Okay. Second condition, seismographs located beyond 145 degree from the epicenter, there is arrival of P waves but not the S waves. Let's in figure 145 degree, there is arrival of, beyond 145 degree there is arrival of P waves. Means there is no shadow zone for P waves beyond 145 degree, but in the case of S waves there is no recordance of S wave. So beyond 145 degrees and 145 degree, there is a shadow zone for the S waves, which is written in this sentence. Located beyond 145 degree from the epicenter, there is arrival of P waves but not that of S waves. Understand? Third one, A zone between the 105 degree to 145 degree from the epicenter, there is identifies shadow zone for both type of the waves. See, in this region 105 to 145 degree, there is no recordance of p waves, so there is a existence of shadow zone for p waves. In the case of s waves, after 105 degree, in whole area there is no recordance of s waves, so there is a whole shadow zone for the s waves. So this is written between 105 to 145 degree, sorry, no degree, there is angular area. Thus a zone between the 105 degree and 145 degree angular area from the epicenter, there is a shadow zone for both type of the waves, and beyond the 105 degree does not receive any s waves. So all completely shadow zone for the s waves. If this is the figure, see out this figure and clearly understand with the help of this figure. If stated in one brief sentence, we can say about less than 105 degree angular area, no shadow zone for P and S wave, because both waves are recorded by the seismograph. 105 to 145 degree, shadow zones for both, because both P and S waves are not recorded by the seismograph. And greater than 145 degree, there is only shadow zone for S wave, because the P waves recorded by the seismograph, as you clearly see in this figure. Okay, understand? Next one, the shadow zone of S wave is much larger than that of P wave, also shown in figure. This is the area of the shadow zone of S wave, much larger than the shadow zone of P waves. The shadow zone of P waves appears at a band around the Earth between 105 and 145 away degree away from the epicenter. The shadow zone of S waves is not only larger in extent, but it is over 40% of the total Earth surface. So there is a shadow zone for S waves around 40% of the Earth surface area. This is the all about the shadow zones of earthquake waves, which is this concept is very important for the all type of the examinations. So these videos, please share, like to your friends, and please subscribe this teachers knowledge channel. We will meet you soon in next lecture. Thank you.